Hello children, welcome everybody to channel Sube. Today I am going to discuss question number 37, MCQ 37 of 2019 Physics new syllabus paper. For optimum operation of a light emitting diode, that means LED, forward voltage and current should be 2 volt and 10 milliampere respectively. Transistor is having V base emitter equals 0.7 volt, current gain beta 100 and VCE saturated equals 0.1 volt. For the circuit shown in the figure, what are the values of RB and RC for the optimum operation of the LED? So there are 5 answers. So let's try to solve this problem. So children, first of all, let's mark the values they have given in the question in this diagram, like this. The voltage is given for diode, for the LED. The suitable voltage is 2 volt. Then the voltage between collector and emitter is 0.1, and the current through this diode given as 10 milliampere. So children, the same current flows in this resistor 2 because it is series with this LED, and also the same current flows through this transistor as well because all these three are series to each other. Therefore we can mark 10 milliampere here, that we can use when we calculate the value RC. We can take this value as the current through this resistor. Then this voltage we can use 5 volt, that is VCC, the supply voltage. We give it by a battery, connecting a battery to this side and this side like this. Normally that is how we supply power to circuits. So the supply is called VCC. So that is what here they have marked. So since this total distance has a 5 volt, then from that 5 volt this 2 volt is given to this diode, this 0.1 volt is given to this transistor. So we have to find the remaining value from this 5 volt. First let us subtract this 2 volt because that is easy. Then 2 from 5 is 3. Then from that 3 let's subtract this 0.1 volt, then 2.9 volt here in between these points. These points, the voltage is 2.9. That is easy. From 5 volt we subtracted 2 volt and 0.1 volt, then the remaining is 2.9 volt. So that is the value for RC. So we know the voltage between RC and we know the current through it, so we can find the value for RC. So for RC we can write, that is the topic, V equals IR, because since it is a resistor we can use this equation, but you can't use Ohm's equation for this diode and neither for this transistor because they are semiconductors. Only for metallic resistors, passive resistors, we can use this equation. So voltage we can substitute as 2.9 that we found here, and the current 10 milliampere. We have to convert it to ampere by multiplying 10 power minus 3. Then we don't know what RC. So RC here we get 290 ohm. So RC now we have found. So that is that value included in this question, answer 3 and answer 5 both. Therefore we have to do more calculations. That means we have to find this RB also, otherwise we can't select the suitable answer from these two. So so children, what is the voltage between these 2 points? That is 5 volt, because they have given it, because this line continues and also this line continues to this junction. Therefore there are 5 volts here as well. We took it from here and now we take it from this left side. So there are 5 volts given to these both resistors. How current flows? You can mark it. Current flows like this through this resistor and through this resistor as well. So therefore these resistors are series to each other, this one and this 1.7 kilo ohm resistor. But there is a current along this branch, but that is very neglectable. It is very small. Therefore we can neglect it because this resistor is very high. Therefore we can consider these two resistors as series. Then we can check the voltage between these two levels. So imagine, so take this total resistance. How much? 7, 8, 9, 10, 0, then 3, 4, 5. 5.0 kilo ohm. There are 5.5, just we say 5 kilo ohms are there. So 5 volts is given to 5 kilo ohm. 5 volt is given to 5 kilo ohm. Then what is the voltage for 1 kilo ohm? 5 volts is given to 5 kilo ohm. So what is the voltage for 1 kilo ohm? Obviously 1 volt. For 1 kilo ohm 1 volt is given. So here 1.7 kilo ohm is there. Then what is the voltage between that resistor? 1.7 volt. Very easy, 1.7 volt. So 1.7 volt is there between these two junctions. So there is a drop here between base and emitter, 0.7 volt. That is given in the question. So the current flow through this resistor, and at this junction some current flows through this base resistor and through this diode of the transistor and to the ground, and some current passes through this 1.7 kilo ohm resistor and that also go to the ground. So these two parts, two branches are parallel to each other, because the current separate from this junction along these two branches and meet each other at this junction. So these branches are parallel to each other. I can remove this. I remove this resistor because then it will be easy. Otherwise you will get confused. we don't want that, because since those branches are parallel, now we can give this 1.7 volt to this branch as well, because the voltage is equal across both the branches. So we don't want this branch now, we have finished talking about that earlier. So the voltage between these two junctions is this value 1.7. So from that 1.7, 0.7 is dropped across this diode. So the remaining voltage is then 1 volt. That 1 volt drops across this RB resistor. Therefore the voltage between the points of this RB resistor is 1 volt. So now we can calculate the value for RB, because we know the voltage is 1 volt. We can find the current. How? They have given beta. Beta is IC divided by IB. So we know IC is this value 10 milliampere. So 10 milliampere. IB is, so this beta is 100. So that 100 goes to the denominator. So here, then IB is how much? 0.1 milliampere. Remember, this 10 is milliampere. So 0.1 milliampere. So we can use it here now. 0.1 milliampere convert into ampere by multiplying 10 power minus 3. So we know the voltage, we know the current, so we can use V equals IR equation to find out the value for R. So 0.1 times 10 power minus 3 R base. So R base is now 10,000 ohm. That means 10 kilo ohm. So finish. The answer is 10 kilo ohm, 290 ohm, this one 5. So children, it is very easy. This 1.7 is given by this 5 volt. Then from this 1.7, 0.7 is given to the transistor. The remaining 1 volt is given to this resistor. So that is how we calculated the value for R base. So I think you can understand that. If you are happy, please subscribe my channel, do me a little help. See you tomorrow. Goodbye.